Hi, and welcome to another Hopper on microcontrollers video. Hopper is a modern semicolon and curly brace language similar to Java or C#, but designed to run on small devices like Raspberry Pi Picos. Um, or, all of these are RP2040 clone boards compatible to the Raspberry Pi Pico W, or it'll run on 8-bit CPUs like a 6502. This video is specifically about the support of SD cards or micro SD cards in the file system on Hopper. So it's both a microcontrollers video and a language video. Hopper has a file system that's on these cards already, on these devices, that uses the built-in flash. And that's where we upload our programs to, for example. So if we look at I right-clicked on file there to take me to the file unit. It has file APIs, exists, delete, get the size, all that, read, open one, read a line, read, append, flush. And they look very similar to C#, and that's deliberate. So if you know what they do in C#, you know what they do here already. If I right-click on directory, it'll show me the directory APIs, similar story. And then it's got some helper utilities for path utilities, like, what's a valid path symbol, give me the file name, give me the directory name, combine, etc. Get the extension, that sort of thing. All right, and that's all worked up to this point with the built-in flash or on Windows with your file system. So depending on whether you're running Hopper on Windows or running Hopper on your microcontroller. This entire environment, this development environment, is running on Windows. It's all built in Hopper. This editor is written in Hopper. The whole tool chain, compiler, preprocessor, compiler, optimizer, code generator is all written in Hopper. The debugger is written in Hopper. It's got a full debugger for remotely debugging with your devices. Anyway, this little function here is going to walk the root directory in the built-in flash, and it's going to enumerate it. So let's recursively walk it. Let's have a quick look at these devices. Historically, they used to just come in this form, a big old external device that has one purpose, which is to put a full-size SD card in it. And then they started appearing on other devices, like if this legacy TFT LCD display also has a large card reader on the back, right? And that's quite common still today. They'll be on the back of these e-paper devices. There's a micro SD card reader. And they'll be on the back of even little LCDs like this one from Adafruit. Little TFT LCD. These little TFT Adafruit's little TFT LCDs are pretty cool. Then they went one further and they made these RP2040 boards that are designed to do logging. So they'll have other features on board. So this one from Sparkfun, it's got, it can take a LiPo battery and it's got a LiPo battery charger, and it's got an SD card slot on the bottom. Taking it one step further, from iLabs in Sweden, this Challenger board is their logging board. Also got a built-in LiPo charger and LiPo connector. But in addition to the SD card slot, it's also got a real-time clock on board. It doesn't have a backup battery, but it doesn't matter if you've got the LiPo battery installed, you'll be fine. So good logging board. These are all RP2040 boards, all exactly like the Raspberry Pi Pico or W. Anyway, so what I have here, you can barely see it sticking out the side there, but there's an SD card behind that one. So this device, it's the same as this one. So on the back, it's got a little SD card adapter, right? So let's get on with our demo. F7 to build. Preprocessing, bottom of the screen here, optimizing, and then it generated an iHex, which is going to upload. So now I can use the shortcut keys, but they're all on the menu, so I can launch the debugger. Bottom of the screen, it says it uploaded the iHex to my microcontroller. And what I'm using here today is a Sparkfun little tiny microcontroller, also RP2040, nothing special, but I do like the fact that it has a USB-C plug in it and a reset and boot button. And let's run this. So this green text in the black on the top right is actually the serial port connected to the device. So it's like doing serial println from Arduino. But in this system, you can also say echo to display. And when you do that, it'll echo to whatever your configured display is, like that, right? So let's have a look at this. In the root folder, we've got a bin folder and a temp folder. And this is in the built-in flash of the RP2040. Well, it's on the board, it's not in the RP2040. And it'll always have an auto.exe, which is the last program you uploaded, which in this case is the program that's iterating the directory. So if we restart this device not connected to the debugger or not connected to even to the Windows computer, the first thing it'll do is the runtime will look in the bin folder for an auto, and if it's there, it'll run it. And then it has a temp folder, which it's been using. And then it has this folder called SD, which isn't really a folder. You can think of it as a symlink. And that's where it's mounted the SD card. So this is the root directory of the SD card. And on the SD card, we've got a subfolder called content, and in there we've got some text files. And that's what we're going to demonstrate in the next demo. But anyway, so that's how you can see the SD card is mounted into just a default folder, which is always going to be SD. So you can't use the folder SD for anything else on your built-in flash, because it means you've mounted, it means to Hopper that it's an SD drive. Okay, let's exit out of there. And I'll show, this entire console, this editor, the debugger, it's all written in Hopper. Anyway, so what's this program going to do? It's going to initialize the device. Now, this device that we have connected is actually two things in one. So this is how we initialize it, like this. So if I don't tell it which pins the SPI interface is on, it's going to assume the default SPI controller for this device, which is SPI 0. And the pins that are the default pins for it too. So you can configure pretty much the minimal is to tell it which is the data command pin, which is the chip select for the display, and which is the chip select for the device. And these pin names are exactly the same as the ones on the silk screen on the device, and that's very typical. And so if we go and have a look at our device driver, right-clicked on it. Like I said, these pins are the same as the names on the silk screen, except for SPI controller doesn't exist as a pin. And when you call begin to initialize, it'll set up the SD card to use the same pins as the display. And I've noticed that it's important to, even if you're not using it, try to mount the SD card before you initialize the display. And the reason being that the SD card is more finicky about the speed. The SD card driver inside the runtime is more finicky about the speed than the display is. And if the display tries to set the speed after it's already been set, it doesn't get set again. So this works pretty well. And this is about it for the configuration. And then it's using this device driver is using this display driver, a generic display driver for this chip. The SD card doesn't need a driver because it's built into it's got a built-in library here. Doesn't do very much. All it does is mount and eject because it just appears as part of your file system. So you don't need any more APIs for it. Okay, let's run this. Let's launch it into the debugger. There we go. We've loaded it into the debugger. And this demo will do some display testing. And then it'll end by using some file from the SD card to display it. So let's run it. I'm going to hold it close to the screen so we get the light nice. So that's, yeah, it's almost looking green. That's almost looking yellow. The light in the video is always terrible. And there's some shades of gray with black on the right. It's echoing to the serial port what it's doing. It's putting out some sample texture. This font here is the Hitachi font. You can use, you just include whichever font you want to use. And there's a couple of ones available. And there's an image being loaded. It found 4 images in the folder in that, so it tried to do a directory of that sd/content folder, and it found 4 images, of which I decided to just display one. That text file format is my own little sort of run-length encoded version of how to do a bitmap in a text file. And it's pretty slow because it's quite a verbose way of doing a bitmap, but it works. It looks pretty. It's just a demo. Anyway, thank you for watching. I'll link to a video at the end to show how to get Hopper up and running on your Windows machine and for your RP2040 device in about 5 minutes. That's how long it takes to get set up. And I'll link to a playlist of the languages, a languages playlist, so that you can learn a little bit more about the Hopper language if you're interested. Thank you for watching, and I look forward to your feedback.